Here we have an example of a vector, vector b, and as long as we maintain the same direction and the same magnitude or length, this is still vector b, no matter where we move it. Just as we moved vector b around, we can also move this vector a wherever we want it, as long as we maintain its length and its direction. It is still the same vector. So in fact, we can move it here so that its tip and the tail of vector b meet. And what might this represent? This might represent a ship moving in this direction, indicated by the arrow, for the distance indicated by the length of the arrow. And then, at this point, the ship changes direction and moves in a new direction for a new distance. But where is the ship now compared to where it was? The ship is now at this position, but it started here. So let's connect those two. Let me insert an arrow here. All right, now that's a little bit easier to see. And I'm going to call this new vector, vector r, because it is the resultant vector of vector a and vector b. In other words, if we add a and b, this is what we get. We get this result. So actually, let me write that. If we add vector a plus vector b, we get vector r, the resultant vector. And r indicates to us where the ship is now compared to where it was. It indicates its displacement. It not only indicates this distance that it is, it's this distance from its original position, but also the direction it is from its original position. Now, interestingly, because we can move all of these vectors wherever we want them to, as long as we maintain their direction and magnitude, we could have, instead of getting the resultant of a plus b, we could have found the resultant of b plus a. So we're going to imagine that the ship is starting where vector b starts, and it goes in the direction of vector b for a certain distance, and then it turns to go into the direction of vector a, and it travels a longer distance in that direction. The resultant vector is the same. So there you have it. Vector b plus vector a still results in vector r, our resultant vector. The ship started at this position, and it wound up displaced to this position. If we were just talking distance, we would just be talking about the magnitude. But because this vector gives us a direction as well, we do have a vector and we have displacement. Whether the captain of the ship takes this route to the island, or whether the captain takes this route to the island, the ship will wind up at the same place. It has the same resultant displacement.